Hello friends, welcome to the polymer testing section of the polymer process engineering. Here we are going to have an introduction about the importance of the polymer testing, how and why these polymer testing is quite essential, because see, whenever we talk about the polymers, especially they are having several end uses and their application, and to have the knowledge about what different kind of the properties they possess, and also they are whether they are meeting the desired properties or not, the testing is quite essential. So that's why we'll give a brief perspective about that testing, and then how we can ensure about the quality. We are going to discuss about it. So in this particular segment, we are going to cover about the brief introduction, then testing perspective with respect to the quality control, predicting several performance, service performance, then we will discuss about the design data concept, then we will investigate about the failures, then test conditions, then limitation of the testing and sampling, and the quality assurance, the elementary statistical principle we are going to discuss, and then data distribution. We will discuss about the principle of measurement, calibration and traceability. All these things we are going to discuss in this particular segment. Now let us talk about the physical testing of polymeric materials. The physical properties of the material need to be measured for predicting the service performance, whether this particular component is useful for the targeted application or not, to generate the design data, and in case of anything is failed, or if it is not meeting the product desires, in that case we need to investigate the failures. So we need to investigate that particular failure, which is the integral part of the polymer testing. Now without testing, there is no proof of quality and hope of successfully designing of a new product. The polymeric material may be distinct in their properties and therefore procedure for testing. So the particular procedure have been developed and standardized to suit the need of each class of material. For each class of material, there are requirements for recognize and emphasize the particular procedure that have been standardized in each industries. Testing perspective, the polymer is very complex and their behavior is sometimes very unexpected, because it depends on the temperature condition, environmental condition, all these conditions they are attributed, and then it is always desired to have a product with the desired properties. So that is why their behavior need to be addressed, and their behavior need to be studied. So the test of the polymer samples are needed, and they will be well chosen and wide ranging of in order to avoid any kind of embarrassing failure. Now it is important to establish early on that grade of material chosen fully matches the design criteria of the product. Like plastic component, although initially the adequate strength may on constant exposure to detergent for the environmental stress cracking. Now testing may reveal that the material did not meet the designer's specification, or show that some important properties has been overlooked. Now there are four main area of testing. One is the quality control, the second one is the predicting service performance, then design data and investigating failures. Now it is essential to understand the purposes of testing before undertaking any test and considering which properties is to be measured, because the requirement for each of the purposes are different. Now failure of which may lead to time wasting test, as they do not void or they not yield the required results. Now similar to this, failing to comprehend why someone else is performing a specific test can result in misunderstanding and conflict in between the research department and the quality control department of a plant. Now the ability to automate test and the preference of like non-destructive test, this may be added to the different characteristics of testing method, like precision, reproducibility, speed and complexity. Now depending on the goal of the test that is conducted, a different balance of these distinct features and associated cost is used. Each of them will be taken into account in turns, but in every case the precision and repeatability must be suitable for the test being conducted. Let us talk about the quality control test. When testing all of the output, non-destructive approaches are advantageous and even necessary. And the test should be quick and affordable. Automation will likely to speed up the test, and these tests evaluating the performance of the product, usually they are preferred. Now, predicting service performance. The test should be relate to the service condition and aspects of the product performance. It is quite obvious, because suppose if I need to test this particular component in a humid environment, or if I need to use this particular equipment in the humid environment, then it is quite obvious that test should relate this kind of service condition. Even though the speed and cost are less important, the testing shouldn't be too complicated. And NDTs or non-destructive tests are not always appropriate when predicting product performance, as they may be necessary to establish the point at which the failure occurs. Now, for producing the design data, the test pieces are of the simple shape and size, whereas the product may be different geometry and size. Now, the reason is that sometimes you need to have a prototype for the test pieces, but the actual product may be different. So, the information must be given in such a way that the designer can account for modification to the geometry and time scale. So, the designer must aware about this particular aspect. Now, it demands a thorough understanding of the material behavior and frequently several points of data. Now, it costs a lot of money to produce data of this kind, and it is unlikely that the result will be attained very quickly. However, the automation may be helpful, especially when a test must run for a lengthy time, as in the creep test. Now, testing for investigating failure. It is important to understand that the failure mechanism before test to be chosen, and these tests must be relevant. This particular information is quite essential, because in case of a failure, we must need to find out the root cause of that particular failure, and that is why the investigation need to be carried out. The absolute accuracy of the test may not be important, but it should be capable of discriminating between the good and bad product. So, the classification of group of test is important. So, when we talked about the classification, then of course, the classification of the testing can be, these tests relate to the fundamental properties, maybe apparent properties, or maybe the functional properties. Now, the test condition. This includes the different parameters like preparation method of the material, how you prepared for this one, and then what is the storage history. Sometimes the storage history, and if you see that every product you purchase, there is a guideline in every label that it must be stored in this condition. So, what is the storage history? Sometimes it may be under the rough conditions, sometimes it may be under a very conducive environment, all these things. And third one is the other parameters like temperature and velocity. The test procedure requires some attention, as a small deviation can produce the significant changes in the result, and the test condition should be accurately set initially and then monitored through the test. Now, when testing according to the published standard, some of the deviation from the set procedure cannot be avoided, like limitation of the amount of the material available, all those things, because this gives a guiding factor. Now, in such type of a condition, the deviation should have been recorded, and you must find out the root cause of the deviation, and the test report, the procedure should have been stated clearly. Let us talk about the limitation of test results. Now, in a careful environment, the tests are carried out, but there will be some limit to attainable accuracy. The precision of a particular method may be lower than anticipated after considering the interlaboratory variables. Now, it is essential to be conscious of the order of the magnitude of the range within the true result lies. It is not sufficient to present the result the statistician once the tests have been done, and no measurement is exact. There always some uncertainty. Now, uncertainty estimates must be made for every measurement by the calibration laboratories, and it is possible that all accredited testing laboratory will eventually be forced to do the same. Now, it requires the evaluating the uncertainty added by each measurement component, which is not always simple to perform. Let's talk about the sampling. The efficient sampling means selecting the small quantities that are truly representative for much larger entire whole or the significance of the test result, which is closely related to the efficiency of sampling. Circumstances in the financial consideration determine the sampling frequency and the number of test items per sampled item. Now, in a continuous quality control system, testing frequency is more crucial than the number of test pieces at each point. Now, 5 seems to be the optimum number where there are numerous test pieces available, because an odd number is advantageous if the median is to be taken. The efficient sampling is that the small quantity selected and tested be truly representative of much larger whole. The test pieces should be representative of the sample taken, and a sample representative of the batch, and the batch representative of the wider population of the material. Let's talk about the quality control. In order to ensure the product quality, production processes must be controlled, raw material must be inspected, and finished good must be tested. These three are main parameters for good quality control. The physical testing methods, they are important in this particular design. In order to ensure the quality, the majority of tests are performed first. The quality control is often thought as applying only to product, since this affects the lives of the entire population. Only a laboratory where the equipment, the methods, and the workers are all subjected to the quality assurance system can produce the reliable result. For example, the ISO 9000 standards are used widely by the variety of the organization, and their laboratories are covered by the system's broad generalization. These standards address not only the control of test pieces and equipment calibration, but also the training of staff, a topic that is frequently disregarded in discussion of quality control in general. The requirement lists set a high standard, and it has to be recognized that maintenance of these standards is time consuming and difficult. All test equipment should be calibrated, and every parameter relating to that machine requires formal calibration. Now, there is some degree of uncertainty at each level of measurement, and that need to be addressed, and that need to be averaged out. Estimate of uncertainty are included in calibration, providing they maintain proper calibration standard and run a suitable quality system. The accuracy of the reported result is based on both the validity of the data handling and the accuracy of original measurement. The discipline required to maintain an accredited status has a significant impact on the calibration of the test equipment, training, documenting of the test protocol, sample control, and formal audits, all of which serve to reduce errors and maintain the reproducibility. The quality assurance of physical testing and measurement. The intrinsic value and fidelity of any decision depends on the quality of measurements and used for the decision process. For a certain test system, the quality can be described in terms of the uncertainty in the measured result. Good quality equates to a small or low uncertainty. Now, quality for a test system has two major components. One, how well the measured variable relate to the characteristics used to make the decision. And second, the extent of the measured parameter value or values level of uncertainty. The higher the level of uncertainty, the worse the quality. A certain degree of confidence that this quality is reached must be component of any continuing project once a certain level of quality has been established and maintained through the use of a specific control procedure. Let us talk about the elementary statistical principle, test data variation. The variation may be described in terms of a deviation of the output value from a true value which would be obtained for any measurement, and that is desirable for the product accuracy. And all measurements are influenced to some degree by perturbation that influence the measurement process and generate these deviations. And each measurement may be perturbed by one or both two types of deviation. One is the random deviation. Now, these are the positive or a negative variation on a central value which could either be true or a reference value. For a long run series of a repetitive measurement, each test execution yields a unique difference, and the mean value of these differences is 0. Bias or systematic deviation. Now, these are constant offsets of variation from true value. Now, these offsets, which can be positive or negative, they are frequently specific to each given set of test condition. Data distribution. Any specific data value is a part of or derives from a population of values with the specific characteristics known as distribution. A population may be a single object or a limiting mass of material, a finite but large number of object or a large mass of material, a hypothetical infinite number of object or mass materials. The frequency of occurrence of individual data values around a given central value, such as mean or median, is described by the distribution. A probability distribution function that expresses the distribution in terms of a central tendency related distribution parameter is used to describe the distribution. Let us talk about the characterizing distribution, and there are following some elementary concepts of distribution, and it has the characteristics of mean, variance, standard deviation and range. Now, it is assumed that the database has a normal distribution which are represented by two different type of statistical parameters. One with a median or mean as the central value that characterizes the dispersion of values around the central value, the variance and the standard deviation. The mean variance and standard deviation can be realized in two ways. One, as a two parameter value based on extensive measurement, the parameters are designated by symbols mu, small theta, square theta, as estimate of true value based on the samples from the population designated by the symbol xi, S2 and S. Now, this is the mean. Bar x is equal to x1 plus x2 plus x and so on up to xn over n, where x is any data value and n is the total number of sample data value. And variance can be given as S2 is summation of xi minus bar x whole square over n minus 1, and standard deviation that can be represented as summation xi minus bar x to the whole to the power 2 over n minus 1 to the power half. Now, the standard deviation, this provides a measuring unit based approximation of the dispersion around the center value of mean. For a normal distribution, the interval of plus minus theta about the mean mu will contain 68.3% of all values in population, and plus minus 2 theta interval contains 95.5% of the data value, and plus minus 3 theta interval contains 99.7% of the data. A relative or unit free indicator of the dispersion is the coefficient of variation, and this CV can be represented as S over bar x, and CV can be expressed as the ratio or a percentage value. Let us talk about the Z distribution. The normal distribution curve may be characterized by an equation called normal probability density function, which gives the probability of finding a given distribution value as a function of the value. Now, the area under the distribution curve is changed in the function to make it equal to 1, and this corrected equation is known as standard normal distribution. A straightforward change of the origin and scale yields the area of a normal distribution for any variable x with known mean and variance. The x variable, which has a mean and standard deviation, is transformed into the variable z, and which can be represented as z is equal to x minus mu over small theta. For a standard normal distribution, the expected value of z is 0 and the standard deviation is 1. The z distribution are applicable when both the population mean and variance are known. Let us talk about the t distribution. The z distribution and the proportion of sample values that fall within minus plus limits as stated are no longer relevant when the variance must be determined from a sample. The t distribution is employed in this situation, and t is a random variable and can be represented as t is equal to bar xn minus mu over s over square root of n. While the t distribution resembles the typical z distribution in terms of a shape and expects a mean of 0, its variance is determined by the degree of freedom connected to s, which is equal to n minus 1. The t distribution moves closer to the normal or z distribution, and its variance moves closer to 1 as n approaches infinity. Now, this figure represents the z distribution and the t distribution. You can have a look at this. Now, principle of measurement and calibration and traceability measurement. Now, measurement by using a specific technological process that produces the data specific to the class of item or materials. Measurement is essentially a comparison of an unknown to a known or standard object or values. Now, measurement theory, this describes how a measured parameter relates to a specific property, and there are two general type of measurement. One is direct, when the property of interest and measured parameter are the same. Indirect, where the measured parameter has a theoretical connection to the relevant properties, typically a direct or a linear one. The terminology needed for describing measurement: one is the standard, a recognized quantity object or creation used for comparison; a standardization organization's protocol for a certain technical operation or other measuring objective. The measurement system, the entire set of tools or equipment this is required to perform a particular sort of measurement, which typically includes a data recording device. The technique, a technical protocol or procedure utilizing a measurement system created employing a certain scientific theory. The test method, the adoption of a technique to suit a certain action or procedure. It also contains a written guide for performing measurement. The protocol, a strategy and comprehensive list of unambiguous instruction for achieving a certain testing or measuring goals. The absolute method, a technique where the test outcomes are determined by the accepted physical, external or standard values and that are derived directly from the theory. The relative or comparative method, a procedure whereby the test outcomes are evaluated by comparison to the measurement of a reference substance or object. The standard method, a process that a standardization organization has adopted like ASTM, etc. Typically, it is widely accepted in technology and has a declared level of precision. The reference method, a tried and a true technique with consistently high accuracy and showed the great precision. The figures of merit. A measuring system is often chosen for a certain testing purpose based on a set of figures of merit that are applicable to the following crucial characteristics like precision and bias, that is uncertainty in the test results, sensitivity, useful range. Other desirable characteristics like low cost, rapid testing and automated procedure, ruggedness and ease of operation. Let us talk about the precision, biased and uncertainty. A low standard deviation indicates a good precision. defined as the close agreement of measured quantities. Good or high accuracy is the result of a good precision and a little or no biasing. In an inverted sense, the word uncertainty is commonly employed as a substitute of accuracy. That is, the low or acceptable uncertainty is equivalent to the high accuracy. Sensitivity. It is the ability to detect a small difference in the measured properties or the fundamental inherent properties. It can be defined in quantitative terms of physical property measurement. Now, this can be determined as the sensitivity is equal to K over Sm, where K is the slope of relationship between the measured parameter and inherent properties of interest, that is Q is a function of M, and S is the standard deviation of measurement M. The useful range. The range that the instrument respond to in order to measure the property. Appropriate response is expressed in two categories: the presence of a linear relationship between the instrument output versus level of measured property, and the precision biased uncertainty and sensitivity at an acceptable level. Calibration. It is the basic to all measurement system, a set of marking on a scale graduated in the output parameter of a test device. The process of contrasting a measured test result or a value with a value that is generally regarded to be true, referenced or standard. Eliminating bias or systematic departure from measured value so that they perfectly match the true value is one of the calibration's main goal. The requirement for calibration: an estimate of accuracy, precision, biasing in the output measurement or response function, the availability of the documented calibration standards, the presence of a statistical control for the test system, a fully documented protocol along with the experienced person for the calibration. Traceability. It is the capacity to identify or precisely establish the existence of a continuous recognizable or recorded path leading from a fundamental standard or standard values to the targeted measurement system. However, the traceability does not imply any level of quantity, that is the magnitude of uncertainty limit. The traceability is a need for assigning limit of uncertainty on the output or response measurement. Some national standardization laboratories like National Institute of Standard Technology in the USA or National Test House in India, the comparable national meteorological laboratories for all developed countries offer physical standards with certified values as well as the calibration services, like in Indian context, Bureau of Indian Standards, all these things they are providing such kind of services. So dear friends, in this particular section we discussed about the testing of the polymer samples. We discussed about the importance of these tests, how we can perform, and all kind of nitty-gritty which you have discussed. For your convenience, we have enlisted couple of references which you can utilize if you wish. Thank you very much.